but it's a solved problem.
Wait a minute, what if I'm a large company with a proxy and you don't see a lot of transactions in the same place? A lot of users in the same place, so what can you speak on the algorithms?
Well, a lot of times that you'll see is, because you're going through the proxy, you also see that the SSL certificates are linked to that particular machine. There's a lot of classification on geo IP address. There's a lot of sophisticated stuff going on. But yes, corporate proxies are a pain for this type of detection. But given the scale of online banking, then people sitting behind corporate proxies doing this are only a very, very small part of that pain. Okay, so it's a scale problem in this. Question, Matt?
How does the attacker create man-in-the-middle attack? How does he create?
That's another whole presentation. there are lots and lots of different ways. I mean, the key things, man-in-the-middle redirection. So effectively, if I've got a server somewhere, if I can alter the proxy settings in the web browser of the end user, if I can intercept their network traffic, I'm sitting on the same network segment, if I can modify DNS settings or any other network stuff, that's how I can insert my man-in-the-middle. Okay. And there's a whole number of other sort of frameworks of being a little bit more aggressive about inserting man-in-the-middle. Okay. The real thing, though, is the bad guys have moved well beyond that. So the key thing, what we're seeing today, is called man in the browser. Okay. So the man in the middle, that man in the middle is now sitting inside the web browser. Okay. So because you're sitting in the browser, okay, so you can see, so traditional malware, you're normally looking at the system reconfiguration, you've got Trojan applications, you've got operating system hooking and TCP/IP stack and deception. So this is where a key is sort of certain things. Man in the browser goes inside the browser. Okay, so it's operating inside the browser. So all these things about having to load extra applications and get those running and mimicking, or Trojans, having to intercept the stack and things, doesn't matter if you're operating inside the browser. The browser has the secure connection between the end sites. So what does this really mean? So the man in the browser, Trojans, more often they're called now proxy Trojans. They operate from within the web browser by hooking key operating system and web browser APIs and proxy all the HTML data. What this means is that the attacker themselves doesn't care about encryption. That happens at a lower layer. Okay. They can inspect any content sent or received by the browser. They can inject and manipulate any content before rendering it within the browser. And they can dynamically create additional get, post, put, you name it, at any time to any destination from within the browser while the person's operating it. So on a clean system, what you normally expect is the web browser then connects to, transmits data or connects the data to the WinINet, the WinSock, and now it's the internet. So frankly, it's dead simple. The malware now hooks in between the browser and the WinINet. Okay. Isn't sophisticated stuff. In fact, if you use any of your other sort of pen testing tools, then you're probably already doing this in some capacity already. However, the malware themselves are hooking inside the web browser. So what does this really mean for these types of attacks? This means that not only can I steal login credentials, I can ask for more. Okay, so I can do things such as I can add additional pages and additional information before the user logs in. I can do the same sort of thing, adding new things, new pages, new content, new page requests while they're logging in, and I can do it all after they've logged in as well. So at any stage within that conversation with the banking application, I can do all this through the malware. Which means that it makes me a lot easier for me to get away from my attack from social engineering perspective. Okay, so some of the things that we've seen already. So I can request additional data through social engineering. So once someone logs into their banking application, all of a sudden I now have a page that pairs up while they're logged in, complete with the little wee lock on their screen, saying that would I now like to double check or register my credit card details? So that people type in their credit card details and their PIN number, the CVV code, and things like this. Okay. We also see the same page is now asking for additional security questions. So having gone through your normal login phase, it's adding another login phase, asking for your social security number, your mother's maiden name, all these additional things. All the things that you probably need to recover passwords for other accounts and things like that afterwards. Okay. Other things, we're seeing one-time keypads and scratch cards. They're popular in South America for online banking. Every time you log in, you scratch one particular number off, and that's the number that you have to use. The following number is what you use next time you log in. It's one-time password. It's the most secure method. So once you've logged in, it just asks you for the next 2 or 3, and people fill out these details. And so that means that your one-time keypads have been defeated. You can ask people to change their password. So even though you didn't get their full password the first time round, you ask them to change it. And then of course you just say it failed, but you've now got their old password. Okay. You can also then test and resynchronize password and transaction calculators. And I'll get on to a little bit more on that as well. Key thing though, as far as the conversation between the web browser, the user, and the bank, everything is intact. Okay. The bank has no idea this is going on. The web browser has no idea it's going on, and only users that understand that there have been changes to the pages are actually going to be aware of what's going on. So here's one. This is a real one, carefully disguised from the particular bank. So on the right-hand side, here's the normal panel that appears on the login. Here we have one that's been modified through this particular piece of malware sample. So instead of it's asking for username, passwords, and then which country, which state you're doing it from, it's inserted a few extra parts. It's asking for your check card number, your expiration date, and the PIN number and mother's maiden name. I think it was a little bit optimistic of them to be asking that on the login. But people do this. Don't forget, the padlock is still intact. This is the bank's page. Okay, but this has all been added inside the browser. There's no way that the bank knows that this is going on. And of course, any data that's inputted into this will never go back to the bank either, so they wouldn't know that it's been intercepted. Sounds pretty scary. The scary thing that really comes to that particular box is a configuration file. Okay, so this malware and these malware tools are designed to be fully configurable. This particular bank and the scripts that you need for this particular framework and all that, you buy. Okay, so you buy the malware from about $400 to about $1,500, depending on which particular flavor you want to do, whether you want to host it in this country, if you want someone to host the engine for you, or you want to rent the system, whatever. You can buy these configuration files for particular banks. They go for about $5 to $15, depending on which particular bank. So not only do we have these parties that are creating this malware, we have this distribution, and we also have this third-party developers that are developing the configuration and tuning files that go into the malware itself. Okay. So that's all very well about stealing usernames, passwords. What happens when you're on multi-factor authentication and you've got a one-time password, it's your secure ID token and things like that? Doesn't matter. At the end of the day, if you want to, the purpose of breaking into bank accounts is to steal money. Okay. Stealing passwords and usernames are a way to get into the account so you can steal money. What you're really after is that transaction. So even with all these multiple authentication systems and validation systems on the login, it doesn't matter. Okay. What they're now doing is focusing on the money transfer itself. Okay. And we started already seeing this early 2007. It started off in South American banks. Okay. It was driven largely by multi-factor authentication keys, back-end heuristics for logging in, seeing certain IP addresses appearing in different countries and browsers, physical location, and frankly, just malware has improved since that time. So it's become, before I had to go out and build this type of malware myself, I can now just go online and purchase what I need. Okay. And it has all the different features. So because the transfers happen after the person's logged in, it makes it very, very difficult for their banks to actually see what's going on. So these fraudulent transactions are occurring while the user